The universe is a place of endless mystery and profound strangeness. Are you prepared to have everything you thought you knew about space completely turned upside down? We are about to journey through 30 of the most surprising and bizarre facts the cosmos has to offer. These are not just simple trivia, they are mind-bending revelations that challenge the very nature of reality itself. You will discover why a single day can last longer than an entire year, how a planet could be made of solid diamond, and what happens when you cry in the complete silence of the vacuum. By the end of this, your perspective on our place in the cosmos will be permanently altered. What is the one thing about space you find most difficult to wrap your head around? Our journey into the bizarre begins right next door with our so-called sister planet, Venus. While it may look like a tranquil, cloudy world from afar, its reality is a place of pure cosmic contradiction. A single day on Venus, the time it takes for the planet to spin once on its axis, lasts an astonishing 243 Earth days. Now consider its journey around the Sun. A full year on Venus, one complete orbit, takes only 225 Earth days. This is the ultimate planetary paradox, where a day officially outlasts an entire year. The clock simply cannot keep up with the calendar. To understand why, we must look at its spin, which is not just incredibly slow, but also backwards. Imagine a clock running counterclockwise, that is Venus. From its perspective, the Sun would rise in the west and set in the east, a sight unseen on any other planet in our solar system. Scientists believe this retrograde rotation could be the result of a colossal impact in the distant past, a collision so violent it sent the planet spinning the wrong way. Or perhaps it is due to the immense, crushing pressure of its thick atmosphere, creating powerful tidal forces that have gradually slowed its roll over billions of years. The result is a world where the line between day and night blurs into an endless, slow-motion twilight. A single sunrise to sunset would span almost 4 months on Earth. Can you picture living in a place where your birthday arrives twice before you have even finished one full day? This is not just a strange fact, it is a fundamental rethinking of how a world can operate, setting the stage for even greater wonders hidden in the darkness. While Venus presents a temporal paradox, the universe offers a different kind of surprise, one of pure chemical abundance. Drifting near the heart of our Milky Way galaxy is a cosmic brewery of unimaginable scale, a vast interstellar cloud known as Sagittarius B2. Within its swirling depths, astronomers have identified a staggering substance, vinyl alcohol. This is not the type of alcohol you would find in a beverage, but it is a complex organic molecule, and the cloud holds an almost incomprehensible quantity, billions upon billions of liters of it. How does such a complex molecule form in the cold, empty void of space? The process begins with simple atoms and tiny dust grains. In the dense, cold environments of these clouds, atoms like carbon, oxygen, and hydrogen slowly drift and stick to the surfaces of microscopic dust particles. Over millions of years, these atoms link together, building increasingly complex chains and ring structures, all catalyzed by the gentle energy of starlight. The discovery of this alcoholic cloud is far more significant than a simple cosmic curiosity. It is a powerful piece of evidence in the search for life's origins. Vinyl alcohol is what scientists call a prebiotic molecule, a direct precursor to the amino acids and other compounds that form the very foundation of life as we know it. Its presence in such vast quantities suggests that the fundamental ingredients for biology are not rare or unique to Earth, but are being manufactured in great abundance throughout the galaxy, scattered by stellar winds and comet impacts to potentially seed new worlds. To grasp the sheer magnitude of this reservoir, picture a cloud so immense it spans an area of space many light years across. The total amount of alcohol within it is beyond any human scale, enough to fill every ocean on Earth countless times over. Yet, despite this, you could never take a sip from this cosmic cocktail. The cloud is a vacuum far emptier than any we can create on Earth. Its molecules spread so thinly that a spaceship flying through it would encounter only a handful per cubic meter. The temperatures are hundreds of degrees below zero, and the radiation from the nearby galactic core is utterly lethal. This cloud is not a destination but a testament. It reveals a universe that is not barren but chemically rich and creative, constantly assembling the very pieces from which new worlds and perhaps new life could one day emerge. The silent, airless void of the moon acts as a perfect cosmic museum. Unlike the shifting sands of a beach erased by the next tide, the footprints left by the Apollo astronauts are not just historical markers, they are near-permanent sculptures etched into the surface with an expectation to last for millions of years. The secret to their incredible longevity lies in what the moon lacks: an atmosphere. Here on Earth, our weather is a relentless artist of erosion. Wind scatters dust, rain dissolves and rearranges soil, and even the gentle force of humidity and frost work to smooth every sharp edge over time. The moon knows none of this. It exists in a perpetual, profound vacuum, a place without weather, without wind, and without water. This absolute stillness means that once an impression is made, there is no natural force to wipe it clean. The very soil itself, known as regolith, is perfectly suited to hold a shape. It is not like soft sand, but a fine, glassy powder created by eons of micrometeorite impacts pulverizing the lunar rock. When an astronaut stepped onto this surface, their boot compressed this layer of fine dust into a cohesive, almost concrete-like imprint. Think of it like pressing your hand into freshly fallen, dry snow. The impression holds its form because the individual crystals lock together. On the moon, without any air or moisture to disturb them, those locked crystals stay exactly as they were left. So while a footprint on a terrestrial beach might vanish in hours, its lunar counterpart will likely outlast the pyramids, a silent testament to human exploration waiting patiently in the dust for epochs to come. Our cosmic neighborhood is ruled by a single, overwhelming presence. Every planet, every moon, every drifting speck of dust in our solar system is utterly dominated by the Sun, which alone contains a staggering 99.86% of the entire system's mass. Picture everything you have ever known, from the giant storms of Jupiter to the rings of Saturn, from the deserts of Mars to our own blue Earth. All of it combined amounts to a mere fraction of a percent of the total. To grasp this immense imbalance, imagine a standard bowling ball placed in the center of a room. This represents our Sun. In this scale model, the planet Jupiter, the solar system's largest planet, would be nothing more than a single golf ball orbiting it. And our own Earth, the only home we have ever known, would be smaller than a single pea. This is the true hierarchy of our celestial home. This overwhelming concentration of mass is the invisible hand that governs all motion. It is the Sun's immense gravity, born from its sheer weight, that commands the planets to orbit. They are not flying through space of their own accord. They are forever falling towards this colossal anchor, their forward velocity just enough to keep them in an endless, graceful fall around it. This gravitational dominance is the very reason for the solar system's existence and its enduring stability. The entire system formed from a collapsing cloud of gas and dust, and as it collapsed, the vast majority of that material, drawn by its own gravity, pooled at the center to ignite the Sun. The leftover crumbs, that 0.14%, were all that remained to swirl together and build the planets. Our entire world, with all its complexity and life, was fashioned from cosmic leftovers. This fact redefines our place in the universe, not as the center of anything, but as inhabitants of a tiny, precious fragment of material that somehow escaped a gravitational titan. This staggering density forces us to confront the true power of gravity. Within a neutron star, the very structure of matter has been erased and rewritten. The immense gravitational pressure of a stellar corpse, often more massive than our entire sun but compressed into a sphere the size of a city, is so overwhelming that it achieves the impossible. It crushes the atom itself, the vast empty space that makes up an atom. The incredible distance between the orbiting electrons and the central nucleus is completely eliminated. Under this cosmic vise, electrons are forcibly slammed into protons, their opposite charges cancelling out to form a sea of pure neutrons. The result is a material unlike any other, a neutron soup of almost unimaginable density where a single sugar cube's worth would weigh billions of tons back on Earth. To put that into a human perspective, one single teaspoon of this neutron star material would weigh as much as every single person alive today, all combined into one unimaginable mass. We can never visit such a place, as its surface gravity would instantly crush any spacecraft into a thin film of atoms, but we can observe them from the safety of interstellar space. Many neutron stars reveal themselves as pulsars, spinning dizzyingly fast and emitting beams of radiation from their magnetic poles like a cosmic lighthouse. Each time this beam sweeps past Earth, our telescopes detect a regular pulse, a precise cosmic clock ticking in the void. These distant, spinning beacons are our only window into the behavior of matter under conditions so extreme they defy every intuition we have about the solidity of the world around us. Beyond the crushing density of dead stars lies a world forged from pure fantasy. Astronomers have identified a planet known as 55 Cancri E that is likely a massive diamond floating in space. This super-Earth is about twice our planet's size but carries 8 times its mass, and it orbits so close to its parent star that an entire year flashes by in just 18 hours. The secret to its incredible composition is carbon. While Earth is rich in oxygen and silicon, this world is dominated by carbon, the same element found in coal and graphite. Under the immense pressures and searing temperatures within the planet, scientists believe this carbon has been compressed into a crystalline structure, forming a layer of diamond that could be thousands of miles thick. Imagine a landscape not of rock and water, but of glittering, solid carbon. Yet this jeweled world is no paradise. Its surface is a vision of hell, perpetually baked by its nearby star, with temperatures soaring high enough to melt rock. Vast oceans of incandescent lava are thought to cover its surface, glowing fiercely against the dark backdrop of space. The very idea of mining such a world is a logistical nightmare, a venture that would require surviving a scorching inferno while trying to extract a material that is, on a cosmic scale, surprisingly common. This diamond planet is a profound reminder of the sheer diversity of worlds that must exist. It tells us that the ingredients for planets are not uniform, and under the right conditions of heat, pressure, and chemistry, the universe can create wonders that defy our wildest dreams. This profound silence extends even to the most violent cosmic events. In the vacuum of space, sound as we understand it does not exist. Sound is a pressure wave, a ripple that needs a medium to travel through, whether it is the molecules in our air, the water in our oceans, or the solid ground beneath our feet. Out there, in the near-perfect emptiness between worlds, there is no such medium. The air has vanished. This means that even the most cataclysmic explosion in the universe, the detonation of a massive star in a supernova, happens in absolute, eerie quiet. You could be floating right beside it, watching a sphere of fire brighter than a billion suns tear itself apart, and you would hear nothing at all. The blinding light would wash over you, the shockwave of radiation and particles might vaporize you, but your ears would detect only the silence of your own body. This reality is a stark contrast to the dramatic soundscapes of science fiction films, where spacecraft roar and lasers sizzle. Those sounds are added for our benefit to make the experience relatable and thrilling. But the true soundtrack of the cosmos is a profound and perpetual hush. So how do astronauts on a spacewalk communicate? They use radio waves. These are a form of light completely different from sound, and they can travel perfectly well through a vacuum. Their words are converted into radio signals sent to their partner's receiver, and then turned back into sound inside the helmet, creating a tiny, personal pocket of atmosphere for their conversation. It is a strange thought that the universe's grandest performances, the collisions of galaxies and the death cries of stars, all play out on a stage of infinite, undisturbed silence. That profound silence is matched by an equally profound cold, a chill so deep it defines the very limits of temperature itself. The record for the coldest natural place in the universe does not belong to some distant, shadowy void between galaxies. It exists right here in our own cosmic backyard, within a beautiful and ghostly structure called the Boomerang Nebula. This cloud of gas, the final breath of a dying star, has a temperature of nearly 458 degrees below 0 Fahrenheit. That is just one single degree above the absolute coldest temperature possible, a state known as absolute zero where all atomic motion theoretically ceases. The mechanism for this incredible cold is a cosmic refrigerator effect. The central star is expelling its outer layers at a staggering speed, over 300,000 miles per hour. This gas expands so rapidly that it cools down, much like the way your own breath feels cool when you blow it out with pursed lips. In the near vacuum of space, this expansion cools the nebula to a temperature even lower than the faint background warmth left over from the Big Bang itself. Yet, in a stunning twist, the absolute coldest temperatures we know of are not found in deep space. They have been created by scientists in laboratories right here on Earth. Using advanced lasers and magnetic traps, researchers have managed to cool atoms to within a tiny fraction of a degree above absolute zero. At these extreme lows, the bizarre rules of quantum mechanics take over, and atoms begin to behave as a single wave of matter, a state known as a Bose-Einstein condensate. So the ultimate cold is not an alien phenomenon, but a frontier we are actively exploring on our own planet, pushing the boundaries of what is possible and proving that some of the universe's most extreme secrets can be unlocked right here at home. The cosmic chill of the Boomerang Nebula gives way to a revelation of staggering numbers. We often hear that there are more stars in the universe than grains of sand on all the beaches on Earth, but the true scale of this statement is almost beyond comprehension. Let us put some actual numbers to this cosmic accounting. Astronomers estimate the number of stars in the observable universe to be around 1 septillion. That is a 1 followed by 24 zeros. Now consider every single grain of sand on every beach and in every desert across our entire planet. The total number of those grains is estimated to be roughly 7.5 quintillion. A quintillion is a 1 followed by only 18 zeros. This means that for every single grain of sand you could possibly hold in your hand, there are over 10,000 stars shining in the cosmos. To visualize this, picture standing on a vast, endless beach. The sand stretches to the horizon in every direction, a number so large it feels infinite. Now imagine that for every one of those grains you are given 10,000 glowing stars. The beach itself would vanish, instantly replaced by a swirling galaxy of lights so dense and numerous that the original grain of sand is utterly lost in the stellar multitude. This analogy only grows more powerful when you remember that our own Milky Way is just one of an estimated 2 trillion galaxies in the observable universe, each one a colossal island of billions or even trillions of stars. The next time you are at a shoreline, scoop up a handful of sand and look at it. You are not just holding tiny fragments of rock, you are holding a key to understanding our true place in the cosmos, a physical reminder that the universe is a place of such immense grandeur that it can turn a whole planet's worth of sand into a single, humble unit of measurement. That immense, star-filled cosmos presents a very immediate and personal challenge for the human body. In the weightless environment of space, even the simple human act of crying becomes a strange and uncomfortable ordeal. Without gravity to pull them down, tears do not fall. Instead, they pool across your eyeball, clinging to the surface with surface tension that refuses to break. If you keep crying, this liquid builds up into a giant, wobbly bubble that completely covers your eye. It is a bizarre sensation, like having your vision smeared with a watery lens that will not clear. Astronauts have described how this bubble can grow so large it eventually detaches and floats away as a perfect, shimmering sphere of saline, a tiny, personal planet of sorrow drifting through the cabin. Beyond the blurry vision, the salt in the tears can cause a real stinging sensation against your eye, making the emotional experience physically painful. This peculiar fact is just one small part of a much larger story, the profound and ongoing struggle of the human body to adapt to an environment for which it was never designed. Our entire physiology evolved under the constant, relentless pull of Earth's gravity. Our inner ear, which gives us our sense of balance, becomes confused, leading to debilitating space sickness for many. Fluids, no longer pulled downward, redistribute evenly throughout the body, causing faces to become puffy and legs to grow thinner, a phenomenon astronauts call bird legs. Even your spine, freed from compression, lengthens, making you temporarily taller by an inch or two. Every single system, from your cardiovascular system to your muscle mass, is challenged by this new reality. The cosmos is not just a place we visit, it is a place that actively reshapes us, revealing how deeply tied our very biology is to the world we call home. Even as your tears would float away in that weightless environment, the very ground beneath our feet is engaged in a slow, cosmic dance with its eternal partner. The moon is not a fixed beacon in our sky. It is slowly retreating from us, moving about 1.5 inches further away from Earth with every passing year. This gradual departure is driven by the same force that gives our oceans their rhythm, the moon's own gravitational pull. The moon's gravity tugs on Earth, most visibly by creating the ocean's bulges we know as high and low tides. But Earth is also spinning rapidly on its axis, much faster than the moon orbits around us. This spin drags the watery bulge created by the moon slightly ahead of it. That massive tidal bulge, in turn, exerts its own gravitational pull on the moon. This gentle but constant tug acts like a slight gravitational slingshot, pulling the moon forward in its orbit and giving it a tiny bit of extra energy. Energy cannot be created from nothing, so this boost for the moon has to come from somewhere. It is siphoned directly from Earth's own rotational energy. Our planet's spin is very gradually slowing down as a result, making our days ever so slightly longer. In the distant future, this slow transfer of energy will lead to a profound shift. Billions of years from now, a day on Earth will have stretched to be as long as a month is today, and the moon will appear noticeably smaller in the sky. Eventually, Earth and the moon will become tidally locked, forever facing each other with the same sides, a final, silent embrace in the cooling darkness. This slow drift of the moon is a gentle reminder that our world is in constant flux, yet some of the most dramatic changes are happening on a microscopic scale, right inside orbiting spacecraft. Scientists were shocked to discover that some bacteria, including the common foodborne pathogen Salmonella, do not just survive in the weightlessness of space, they actually thrive and become more dangerous. Experiments conducted aboard the International Space Station revealed that Salmonella cultured in microgravity became significantly more virulent, meaning it was better at causing disease when compared to identical bacteria grown on Earth. The bacteria did not mutate into a new species. Instead, the unique environment of spaceflight triggered a change in how their genes operated. It appears that the absence of gravity places a new kind of stress on the bacterial cells, and in response, they activate a different set of genetic switches. This altered gene expression transforms them, making them more potent and resilient. For astronauts on long-duration missions, this finding carries serious implications. A common stomach bug that might mean a few days of discomfort on Earth could become a mission-critical emergency millions of miles from the nearest hospital. This new understanding is driving major advancements in spacecraft hygiene and medical preparedness. Yet, this strange phenomenon also opens a door to a novel way of fighting disease back on the ground. By studying how and why bacteria become more virulent in space, researchers can identify the precise genetic pathways that control their deadliness. This gives us a unique window into the fundamental mechanics of infection, potentially leading to new drugs or vaccines that can block those same pathways on Earth, turning a cosmic hazard into a terrestrial breakthrough. Jupiter's Great Red Spot is a storm of almost mythical proportions, a churning vortex of gas that has raged for at least 4 centuries. When early astronomers first trained their telescopes on Jupiter, this colossal brick-red eye stared back from the giant planet's cloud tops. For generations, it was a permanent fixture, so vast that 3 planet Earths could be lined up across its width. Yet this ancient landmark is undergoing a profound transformation. Modern observations confirm the spot is shrinking, and its once oval shape is becoming more circular. While it is still an immense tempest, large enough to swallow our entire world, its slow and steady decline poses a fundamental question about the nature of gas giants. What could possibly power a storm that outlasts civilizations, and what force is now causing it to fade? The Great Red Spot is essentially a hypercane, an anticyclonic storm perched between 2 of Jupiter's ferocious jet streams. Its longevity comes from having no solid ground to disrupt it. It simply feeds on the heat rising from Jupiter's deep, hot interior and the smaller storms it constantly consumes. There are no mountains to break it apart, no continents to sap its energy. It is a self-sustaining engine in an atmosphere of hydrogen and helium. Watching a time lapse of its changes is like watching a cosmic clock tick. The spot contracts, it swells slightly, but the overall trend is a gradual diminishment. Some scientists speculate it could eventually stabilize as a much smaller storm, or perhaps in another few centuries it might dissipate entirely, leaving Jupiter's face unrecognizable to future skywatchers. Its fate is a reminder that even the most permanent-looking features in our solar system are merely temporary performances in an endless cosmic dance. Our sun-scorched perception of the Moon and Mercury is fundamentally wrong. These seemingly barren, airless worlds hold a precious secret locked away in their darkest corners: water ice. While their sunlit surfaces bake at temperatures hot enough to melt lead, the deep, shadowed floors of craters at their poles never see a single ray of sunlight. These are permanent cold traps, with temperatures plummeting to hundreds of degrees below zero, creating the perfect deep freeze to preserve water for billions of years. This water did not form on these worlds. It was delivered by cosmic travelers, comets, and water-rich asteroids that smashed into the surface in the distant past. Most of that water would have instantly vaporized in the vacuum of space, but any that happened to land in these permanently shadowed regions found a permanent icy tomb, sheltered from the evaporating power of the sun. This discovery shatters the old image of a completely dry moon and a blistering Mercury. The implications of this hidden resource are monumental for the future of human space exploration. Water is the oil of the solar system. It is not just essential for astronauts to drink. It can be split into its basic components, hydrogen and oxygen, which are the fundamental ingredients for the most powerful rocket fuels we use. A lunar outpost situated near one of these icy deposits could, in theory, mine this water to create a filling station for spacecraft. This would completely change the economics of deep space travel, turning the moon from a destination into a galactic gas station, a vital stepping stone from which humanity could launch its journey to Mars and beyond. These shadowed craters, the coldest places in the inner solar system, have become the most promising real estate for our future among the stars. Even our most powerful eyes in the sky operate in ways that defy our everyday expectations. The iconic Hubble Space Telescope, responsible for some of the most breathtaking images of the cosmos, possesses a surprising limitation: it cannot zoom. Unlike the camera on your phone, Hubble's cameras have fixed focal lengths. They are powerful but rigid eyes, unable to magnify a scene once they are locked onto a target. So how does it capture such staggeringly detailed portraits of galaxies billions of light years away? The secret lies not in optical zoom, but in a combination of sheer technological prowess and its perfect vantage point. Hubble's cameras are equipped with incredibly high-resolution sensors, and it uses a technique called long-exposure photography. It will stare at a single, seemingly empty patch of sky for days on end, gathering every single photon of light that arrives. This patient accumulation allows it to see objects so faint they are completely invisible to other telescopes. Furthermore, by orbiting high above Earth's turbulent atmosphere, it avoids the blurring that makes stars twinkle. From the ground, our air distorts light, smearing fine details into a fuzzy haze. Hubble's crystal-clear view from the vacuum of space is what gives its images their legendary sharpness. To create those wide, sweeping cosmic landscapes, astronomers don't twist a zoom lens. Instead, they take multiple individual photographs, like assembling a giant mosaic, and stitch them together with painstaking precision. The famous Hubble Deep Field image, which revealed thousands of previously unseen galaxies in a patch of sky no bigger than a grain of sand held at arm's length, was constructed this way. It is a testament to the power of patience and perspective, proving that sometimes to see the universe more clearly, you need to stand perfectly still and simply gather the light. Voyager 1 is now a citizen of the galaxy. This small, intrepid spacecraft, launched in 1977, achieved the impossible in August 2012, becoming the first human-made object to leave our solar system and enter the vast, unexplored realm of interstellar space. Its milestone was crossing a theoretical boundary known as the heliopause. Until that point, Voyager was sailing through the Sun's extended atmosphere, a bubble of charged particles called the solar wind. Crossing the heliopause was like a ship finally breaking through the final surf and reaching the open ocean. The instruments recorded a dramatic drop in solar particles and a corresponding surge in cosmic rays from deep space. It had officially departed our star's protective bubble. Bolted to its side is a time capsule for the ages, the Golden Record. This 12-inch gold-plated copper disc contains a curated portrait of Earth with greetings in 55 languages, the sounds of whales and thunderstorms, music from Beethoven to Chuck Berry, and 116 images encoded in analog form. It is a message in a bottle cast into the cosmic sea, a testament to who we were in the late 20th century, intended for any civilization that might one day find this silent traveler. Today, Voyager 1 is over 15 billion miles away, its signals traveling at the speed of light, taking more than 22 hours to reach us. Its nuclear power source is slowly decaying, and one by one, its instruments are being shut down to conserve energy. Sometime around 2025, it will fall silent forever, its final transmissions ceasing as it continues its eternal, silent drift toward the unknown. It will never encounter another star for tens of thousands of years, a ghost ship carrying our whispers into the endless night. The silent drift of Voyager is a stark contrast to the violent electrical storms that rage on other worlds. Our own planet experiences spectacular lightning, but these terrestrial displays are dwarfed by the colossal discharges found elsewhere in our solar system. Even Earth's upper atmosphere hosts its own bizarre electrical phenomena known as sprites and elves. Sprites are massive, fleeting bursts of red light that flash high above thunderstorms, resembling giant, glowing jellyfish with dangling tendrils that can stretch for dozens of miles. Elves are even more ethereal, forming immense, expanding rings of light that can span hundreds of miles in a fraction of a second. These are not lightning in the traditional sense, but the result of electromagnetic pulses shooting up from powerful storms far below, briefly setting the thin air aglow. Yet for all their grandeur, they are mere sparks compared to the planetary scale fury of Jupiter. The gas giant is a cauldron of perpetual storming, and its lightning bolts are monstrous. They are hundreds of times more powerful than anything recorded on Earth, and they generate continuous, booming radio signals that our instruments can detect across the gulf of space. These aren't brief cracks of thunder, but a never-ending roar of static from a world where storms can last for centuries. The true alchemy of alien lightning, however, may be happening even further out in the icy atmospheres of Neptune and Uranus. Scientists theorize that the immense pressure and unique chemistry in these planets' depths could turn lightning into a gemstone factory. The powerful electrical discharges might tear apart methane molecules, freeing carbon atoms. Under the crushing pressures deep within these atmospheres, those carbon atoms could be compressed into crystalline structures, literally raining diamonds. Picture a world where a storm does not bring water, but a shower of solid gems sinking toward a hypothetical rocky core. Studying these alien weather systems is far more than cataloging curiosities. It provides a crucial laboratory for understanding the fundamental physics of atmospheres, chemistry, and energy. By observing how weather operates under such extreme and varied conditions, we can refine our models for planetary formation and climate, helping us to better understand not only our neighbors, but the very nature of worlds orbiting distant stars. That faint, uniform chill permeating the depths of space is not an accident. It is the dying ember of the universe's birth, a fossilized echo of light from the very beginning of everything. This is the cosmic microwave background radiation, and it gives the entire cosmos a baseline temperature of about 454 degrees below 0 Fahrenheit. That is just a few degrees above the absolute coldest temperature possible. This energy did not come from any star or galaxy. It is the remnant heat from the Big Bang itself, stretched and cooled over 13.8 billion years until it became a faint microwave whisper that fills every cubic inch of the universe. Its discovery was one of the greatest accidents in scientific history. In the 1960s, two radio astronomers, Arno Penzias and Robert Wilson, were troubleshooting a persistent, annoying hiss in their giant horn antenna. They scrubbed away pigeon droppings and checked every connection, but the noise remained, a constant, isotropic signal coming from every direction in the sky. They had inadvertently stumbled upon the afterglow of creation. This discovery was the final, irrefutable evidence that clinched the Big Bang theory. The universe was not eternal and static, it had a definite, hot beginning. When you look at a map of this cosmic background, you are not looking at stars or galaxies. You are looking at a baby picture of the universe, taken when it was a mere 380,000 years old. At that moment, the expanding, searingly hot plasma of the early universe cooled just enough for atoms to form, allowing light to travel freely for the first time. That first flash of light has been traveling ever since, its wavelength stretched by the expanding universe into the microwaves we detect today. The tiny, mottled variations in this map, the hot and cold spots, are the seeds of all future structure, the gravitational blueprints from which every galaxy, star, and ultimately we ourselves would one day form. You are literally made from the denser patches in that ancient light. Even the color of a sunset is not a universal truth, but a conversation between light and atmosphere. While Earth's sunsets blaze with fiery reds and oranges, the Martian dusk paints the sky in an otherworldly shade of cool, ethereal blue. This stunning reversal of color is a direct result of the Martian environment itself. Our own blue skies and red sunsets are created by a process called Rayleigh scattering, where the molecules in our thick atmosphere are just the right size to scatter shorter blue wavelengths of light in all directions, bathing the daytime sky. At sunset, when sunlight must travel through more atmosphere, the blue light is scattered away, leaving the longer, redder wavelengths to color the horizon. Mars operates on a completely different principle. Its atmosphere is incredibly thin, but it is filled with extremely fine dust particles rich in iron oxide, the same compound that gives the planet its rusty color. These tiny dust grains are much larger than the gas molecules in Earth's air, and they scatter light in the opposite way. They are most effective at scattering the longer, red wavelengths of light out and away from the planet's surface. This leaves the shorter blue light waves to dominate the sky in the immediate vicinity of the Sun as it sets. Imagine standing on the red plains of Mars, the dusty ground glowing a deep ochre under a dim, pinkish sky. As the Sun dips below the horizon, a halo of serene blue light emerges around it, a delicate and beautiful crown in the twilight. It is a quiet, almost melancholic beauty, a daily reminder that the most familiar experiences can be utterly transformed on another world. The serene blue of a Martian sunset gives way to a deep, dark mystery at the very edge of our own solar system. Far beyond the orbit of Neptune, in the frozen, sunless expanse of the Kuiper Belt, a handful of small, icy worlds are behaving very strangely. Their orbits are not random. Instead, they are clustered together, all tilted at a similar angle and swinging out to the farthest points of their journeys around the Sun in a synchronized group. This is like finding several different clocks in a room, all ticking at the same exact second. For astronomers, this precise orbital dance points to one compelling explanation: the gravitational pull of a massive, unseen object. The mathematical evidence suggests this hidden world, nicknamed Planet 9, is a colossal ice giant, perhaps 5 to 10 times the mass of Earth. Its proposed orbit is so vast and elongated that a single trip around the Sun would take between 10 and 20,000 years to complete. At its most distant, this ghost planet would be so far away that our Sun would appear as just another bright star in its black sky. The search for this phantom world is one of the great modern astronomical quests. Telescopes are scanning the predicted swath of the sky, looking for a single, faint pixel of light moving slowly against the backdrop of fixed stars. Finding it would be a monumental achievement, a testament to the power of prediction and gravitational detective work. It would rewrite the textbooks on our solar system's formation, forcing us to ask how such a giant planet ended up in such a strange, wide orbit. Was it flung out there in a chaotic gravitational dance with Jupiter and Saturn in the early days of the solar system? Or does it tell a completely different story of our cosmic neighborhood's birth? Its discovery would confirm that our solar system is not fully mapped, that major worlds can still lurk in the shadows, waiting to be found. That beautiful, steady starlight seen from space reveals a simple truth about our own atmosphere. The romantic twinkling of stars is not a property of the stars themselves, but an illusion created by our own planet. The air around us is not a perfectly still window, it is a turbulent, churning fluid. As starlight travels the immense distance from its source, it arrives as a straight, clean beam. But in the final milliseconds of its journey, it must pierce through Earth's restless atmosphere. Layers of air at different temperatures and densities constantly shift and swirl, acting like countless, imperfect lenses that bend the incoming light. This bending, known as astronomical scintillation, causes the star's apparent position to jitter and its brightness to flicker rapidly. The star appears to dance and shimmer not because it is changing, but because we are looking at it through a bubbling, invisible ocean of gas. This is why the stars seem to twinkle more dramatically on some nights than others. It is a direct measure of the atmospheric turbulence high above you. For astronomers using ground-based telescopes, this twinkling is the enemy of clarity. It smears fine details and blurs the images of distant galaxies, which is why many of the world's most powerful observatories are built on high mountain peaks where the air is thinner and more stable. But ascend above this layer of air and the view transforms completely. From the window of the International Space Station or through the lens of the Hubble Space Telescope, stars do not twinkle. They are sharp, steady, and brilliantly precise points of light, each one a distant sun holding its ground against the black velvet of the void. This unwavering clarity is a key reason why Hubble's images are so phenomenally detailed. It operates in a perfect, natural observatory forever above the weather. Our own galactic home is not an island in a static sea. The Milky Way is on an inescapable collision course with its largest neighbor, the Andromeda Galaxy. These two cosmic titans, drawn together by their immense mutual gravity, are racing toward one another at a breathtaking speed of 70 miles every single second. This is not a random accident, but a gravitational dance that has been unfolding for billions of years and is now reaching its final, fateful act. The merger itself is still an event for the incredibly distant future, set to begin in about 4.5 billion years. When you hear the word collision, you might picture stars smashing into each other in a celestial fireworks display, but the reality is far less destructive and far more beautiful. The spaces within galaxies are overwhelmingly vast. If stars were the size of grains of sand, the average distance between them would be miles. So as these two great spiral galaxies pass through and merge with each other, the stars themselves will simply drift past, like two swarms of bees merging without a single insect touching another. The real drama will unfold in the fabric of the galaxies themselves. Their immense clouds of gas and dust will be violently compressed, triggering a spectacular firestorm of new star formation, lighting up the sky with millions of newborn suns. Over hundreds of millions of years, the gravitational tides will pull and stretch the familiar spiral arms of both galaxies, irrevocably warping their shapes. They will swing past each other, then fall back together again and again until their structures are completely erased. The final product of this billion-year-long cosmic dance will be a new, larger galaxy, a featureless, football-shaped giant known as an elliptical galaxy. Astronomers have already given this future hybrid a name, Milkomda. From the vantage point of any future Earth, the night sky would be transformed beyond recognition, filled with the brilliant, merged light of two combined galaxies, a silent, slow-motion testament to the fact that even the grandest structures in the universe are in a constant, dynamic state of change. Saturn's magnificent rings, long seen as a permanent feature of our solar system, are actually a recent and fleeting spectacle. Data from the Cassini spacecraft's final orbits revealed a shocking truth. These iconic bands are not billions of years old, but likely formed a mere 10 to 100 million years ago. This was a time when dinosaurs still walked the Earth, making the rings younger than many of the species that have evolved on our own planet. Their brilliant appearance is a clue to their youth, as older rings would have been darkened and dimmed by eons of accumulating cosmic dust. So how did such a stunning structure appear so recently in cosmic terms? The prevailing theory points to a catastrophic event in Saturn's neighborhood, the violent destruction of an ancient moon. This icy body may have wandered too close to the giant planet, crossing a gravitational boundary known as the Roche limit. Within this zone, Saturn's tidal forces are stronger than the gravity holding the moon together. The planet's pull would have relentlessly stretched and torn the moon apart, shattering it into countless fragments of ice and rock. These pieces, unable to coalesce back into a single world yet also unable to escape Saturn's gravity, were shepherded into the flat, dazzling disk we see today. But this beautiful arrangement is not eternal. The rings are in a constant state of decay, subjected to a gentle but persistent rain. Micrometeorite impacts and the sun's ultraviolet light electrically charge the tiny ice particles, making them susceptible to Saturn's magnetic field lines. These lines act like invisible highways, funneling the icy material down into the planet's upper atmosphere. Scientists estimate this ring rain drains an amount of water equivalent to an Olympic-sized swimming pool from the rings every single day. At this rate, the entire structure might vanish in another 100 million years. We are living in a privileged moment, a narrow window in cosmic history, to witness one of the most beautiful structures in the solar system, a temporary masterpiece born from destruction and destined to slowly fade away. The sheer violence of planetary formation is on full display at K2141b. This super-Earth orbits so close to its star that its entire year flashes by in less than 7 hours, a proximity that has forged a world of literal hellfire. The planet is so gravitationally locked that one hemisphere permanently faces the star, a condition known as tidal locking. This creates two unimaginably different realms. The star-facing dayside is a crucible with surface temperatures soaring beyond 4,000 degrees Fahrenheit, hot enough not just to melt rock but to vaporize it. Here, vast oceans of incandescent lava stretch to the horizon, churning under the relentless stellar glare. The minerals in this molten rock are torn apart, their components evaporating into a thin, scorching atmosphere of rock vapor. This is where the planet's true fury begins. The incredible heat on the dayside creates supersonic winds, howling at speeds over 3,000 miles per hour, which carry this vaporized rock to the frigid, permanent nightside. On that dark hemisphere, temperatures plummet to hundreds of degrees below zero, a cold so profound it instantly freezes the rock vapor out of the sky. The result is a constant, terrifying precipitation of pebbles and rocks, a rocky sleet that falls into vast, solid plains before being pulled by gravity back toward the lava oceans. This completes a cycle as brutal as it is beautiful, a weather system of vaporized stone and supersonic gales. K2141b presents a world where the very ground you stand on is simultaneously boiling, evaporating, and raining down upon you. It is a stunning example of the raw, untamed physics that can shape a planet, a far cry from the gentle balance of our own world, and a powerful reminder that the universe specializes in extremes we are only beginning to comprehend. The universe is not just a visual spectacle, it is a place with a flavor, deep in the heart of our galaxy, within the same vast dust cloud that holds unimaginable quantities of alcohol. Astronomers made a startlingly sweet discovery. They identified the chemical signature of ethyl formate, the very molecule responsible for the distinct taste of raspberries and the rich aroma of rum. How is it possible to taste a cloud from 25,000 light-years away? The answer lies in the unique fingerprint of light. Every molecule in the universe vibrates at its own specific frequency, and when light from a distant star passes through a cloud like Sagittarius B2, the molecules within it absorb very particular colors of that light. By analyzing the resulting gaps in the spectrum, the dark lines that appear like a cosmic barcode, scientists can determine the exact chemical composition of the cloud without ever leaving Earth. Finding such a specific and familiar compound in the void is more than a quirky fact, it is a profound clue. Ethyl formate is a relatively complex organic molecule, and its presence alongside other prebiotic compounds suggests that the universe is not just a sterile void, but a sophisticated chemical factory. The same fundamental processes that create the flavor of a summer berry are operating on a galactic scale, weaving intricate molecules in the cold darkness between the stars. This implies that the basic building blocks for life, the sugars, acids, and alcohols, are likely common ingredients throughout the cosmos, scattered by stellar winds and comet impacts. So while you could never actually taste the raspberry center of the galaxy, its existence whispers a tantalizing possibility that the recipe for life itself may be written into the very fabric of the Milky Way. This temporary height gain is a direct and personal gift from the microgravity environment. Freed from the constant, crushing pressure of Earth's gravity, your spinal column finally gets to relax and stretch out. Think of your spine not as a single solid bone, but as a stack of individual vertebrae with soft, compressible discs in between them. On Earth, gravity is like an invisible hand constantly pressing down on this stack, squeezing those disks and keeping you at your standard height. The moment you enter the weightlessness of space, that hand is lifted. With no downward force compressing them, the spongy disks between your vertebrae expand, causing the entire spinal column to lengthen. This can result in a height increase of up to 3%, which for an average person translates to an extra inch or two. An astronaut who is 6 feet tall on the launch pad might find themselves standing over 6 feet 2 inches tall in orbit. For a short while, you get to experience life as a slightly taller version of yourself, but this cosmic growth spurt is not without its consequences. The stretching of the spine and the surrounding muscles and ligaments is a significant physical strain. This is why many astronauts experience considerable back pain during their missions, a literal growing pain from living in a new environment. The body is literally being reshaped by its surroundings. This new height, however, is only a temporary condition. The moment an astronaut returns to Earth and gravity reasserts its pull, that invisible hand presses down once more. Over the following days and weeks, the spinal discs are slowly compressed back to their original size, and the astronaut returns to their normal pre-flight height. This cycle of stretching and compression is a powerful physical reminder of how deeply our bodies are tied to our home planet's gentle, persistent pull. Saturn's North Pole holds a secret of almost perfect geometry, a colossal hexagon etched into its cloud tops. Each side of this six-sided figure is wider than our entire planet, a shape so precise it seems artificially drawn. This is no fleeting formation. It has been swirling there for decades, a giant, stable wave in Saturn's raging atmosphere. It is essentially a jet stream, a river of air screaming along at over 200 miles per hour, but somehow this river has been bent into a permanent hexagon. The mechanics of how such a sharp, angled shape forms and sustains itself in a fluid, gaseous environment remains one of the great puzzles of planetary science. On Earth, our jet streams meander in great, wavy loops, never locking into a rigid geometric form for long. Scientists theorize that deep inside Saturn, complex interactions between different layers of the atmosphere create a standing wave pattern, much like the precise patterns you can create by vibrating a plate of liquid. The Cassini spacecraft provided our most stunning views of this phenomenon, its cameras revealing a structure of nested walls and churning storms within the hexagon's boundaries. This polar vortex is unlike any other in our solar system. Jupiter has chaotic clusters of storms at its poles, and Earth has a single, roughly circular polar vortex. But Saturn presents this stark, six-sided figure, a natural wonder that challenges our understanding of fluid dynamics on a planetary scale. It is a humbling reminder that the universe can produce patterns of breathtaking order from the heart of pure chaos. While its surface appears frozen in time, the Moon is far from a dead world. Deep within its ancient crust, the lunar ground still trembles with moonquakes. These are not the same as the quakes we experience on Earth. Our planet's quakes are primarily driven by the shifting of massive tectonic plates, a process that constantly recycles the crust. The Moon, however, has no such plate tectonics. Its rumblings come from more subtle yet equally powerful forces. The Apollo astronauts left behind seismometers, and the data they sent back revealed a surprisingly active world with 4 distinct types of moonquakes. The deepest and most frequent are triggered by the Earth itself. As our planet's gravity pulls on the Moon, it creates immense tidal stresses, stretching and squeezing the lunar interior hundreds of kilometers below the surface. These deep moonquakes are relatively mild but occur with predictable regularity. Then there are the vibrations from meteorite impacts, the literal dings and thuds of space rocks constantly pummeling the surface. The third type comes from the brutal temperature swings. The lunar surface bakes at over 200 degrees Fahrenheit in the sunlight and then plummets to 250 degrees below zero in the shade. This extreme thermal cycling causes the brittle crust to expand and contract, cracking and popping like an old wooden floor. The fourth and most powerful type are the shallow moonquakes, originating just tens of kilometers down. These can register up to 5.5 on the Richter scale and can last for an astonishingly long time, sometimes vibrating the entire moon for over 10 minutes. On Earth, a quake might last for 30 seconds. The moon, with its dry, rigid structure, rings like a giant bell. This seismic symphony tells a profound story about the moon's interior. The existence of deep quakes confirms a partially molten core, while the shallow tremors suggest the moon is still slowly cooling and shrinking, its crust wrinkling like a raisin. Our silent companion in the sky is not so silent after all. It is a world with its own hidden geology, whispering secrets of its inner life with every subtle shake. The geology of Mars is one of extremes, and it is home to the single largest volcano in the entire solar system. Olympus Mons is not merely a mountain, it is a geological behemoth that redefines the very scale of planetary landscapes. This is a shield volcano, a type formed by very fluid lava that spreads out in thin layers, and its dimensions are almost beyond belief. It stands nearly 16 miles high, which is about 2.5 times the height of Mount Everest above sea level. But its true dominance comes from its footprint. The base of Olympus Mons is roughly the size of the entire state of Arizona, a single volcanic structure so vast that a person standing on its surface would not even perceive the slope, as the curvature would be lost over the horizon. Why did Mars, a planet half the size of Earth, produce such an unimaginable giant? The secret lies in what Mars lacks: plate tectonics. On our own world, the crust is a fractured jigsaw puzzle of tectonic plates that slowly drift over the planet's surface. When a plume of hot magma rises from the mantle to create a volcanic hotspot, the plate moves over it, resulting in a chain of volcanoes like the Hawaiian Islands. Mars, however, has a static, single-plate crust. This means that when a massive mantle plume formed beneath the region of Olympus Mons billions of years ago, the crust remained fixed directly above it. For eons, lava steadily poured out from this single, stationary hotspot, layer upon layer, century after century, building a volcanic pile that just kept growing and growing without ever moving. This uninterrupted construction over billions of years created a singular titan instead of a volcanic chain. Today, the great mountain is believed to be extinct, its internal fires long since cooled. It now stands in silent majesty, a frozen monument to the relentless geological forces that once sculpted the red planet, a record of a more fiery past preserved in a world that has since grown quiet. Even the deepest voids between galaxies are not truly empty. The concept of nothingness in space is one of the greatest misconceptions we hold about the cosmos. What we perceive as a perfect vacuum is, in reality, a seething, dynamic sea of activity governed by the bizarre laws of quantum physics. At the tiniest scales, empty space is not empty at all. It is filled with fundamental quantum fields, and from this fabric, pairs of virtual particles and antiparticles constantly flicker into existence, borrowing energy from the universe for an immeasurably brief moment before annihilating each other and vanishing back into the background hum of reality. This endless, frantic dance of creation and destruction is happening everywhere all the time, even in the space between your fingertips as you hold your hand up. Beyond this quantum foam, the void is permeated by things we cannot see. Dark matter, an invisible substance that does not interact with light but whose gravitational pull is strong enough to bind galaxies together, fills the emptiness. Dark energy, an even more mysterious force, is a property of space itself, causing the expansion of the universe to accelerate. The vacuum is also awash with radiation, the faint afterglow of the Big Bang, and the whispered signals from every star and galaxy that has ever existed. So when you look up at the night sky, you are not looking at a sterile, black nothing. You are looking at a vibrant, energetic, and deeply mysterious medium, one that holds the keys to the universe's past and its ultimate fate. The greatest emptiness we can conceive is, in truth, one of the most active and least understood frontiers of all. From the silent, permanent footprints on the moon to the diamond rain on distant worlds, this journey has taken us to the very edges of reality. We have seen a universe where a single day can outlast a year, where tears form floating spheres of sorrow, and where the ground beneath our feet can literally stretch to make us taller. These are not just isolated curiosities, they are fundamental truths about a cosmos that is infinitely stranger, more violent, and more creatively bizarre than our everyday lives could ever suggest. Each fact peels back a layer of the ordinary to reveal the profound wonder operating just beneath the surface. They teach us that the universe operates on a scale of both immense grandeur and intricate delicacy, governed by laws that can seem as magical as they are scientific. This is the real story of the cosmos, a continuous narrative of discovery where every answered question unveils 10 new mysteries waiting in the dark. Our understanding is never complete. It is a living, breathing process of looking up and daring to ask what else is out there. Now we want to hear from you. Which of these 30 facts reshaped your view of the universe the most? Let us know in the comments below and share this journey with someone who needs their perspective shifted. If you are hungry for more mysteries, be sure to subscribe so you do not miss our next exploration into the unknown. Wherever you are, never stop looking up at the stars and wondering what incredible secrets they have yet